Hello students, so we are continuing with our session. So the next one, the previous one was the first paper or the practice sheet of differential calculus. So that's the next one. So let's quickly come to the question directly, and then see there had been request and suggestion to take up miscellaneous question. So that was already in the schedule, bachcho. Okay, so might be after this one or maybe after one integral calculus sheet we'll be taking up miscellaneous followed by integral and one more miscellaneous. So that's in the plan. Okay, so let's see how much I can fulfill, okay, whatever I'm saying, but I will try to do my best, bachcho, for sure. Okay, let's start. See, let fx be the function. So function for x, function of x is 30 minus 2x minus x cube. That's the function of x, and f of n times. That's what f subscript n x represent. So that means f subscript 2 of x will represent the composite function of fx with fx. Okay, similarly f as subscript 3 of x will represent composition of f. Okay, so that's how it goes. Now the number of positive integral values of x which satisfy f 2014 x is less than f 2013 of minus x. Okay, of course, see, the first thing that comes in the mind is that can we go for the pattern like getting f of x, f of fx, f2x, then f of fx, that means f3x, and we may get a pattern. But the moment that idea struck my mind, and I thought about doing it even just for the f of x with the subscript 2, that means f of x. Okay, I realized it's going to be a 9-degree polynomial, so I just left it without writing it. Okay, I just left that idea without even writing it. Okay, so without even initiating it, starting it. So see, then I started thinking the other way around. If I have to solve an inequality, and see, there's a very general statement which is very useful, and I always discuss that in the class, that see, that to solve any inequality, do we need to know the methods to solve inequality depending on the function? My answer is no. Once we know the increasing decreasing characteristic of the function, then it's very clear. Say fx less than g of x, or fx less than f of y. Okay, so it has to be same function on both the side. Okay, if that's the case, now if we know that fx is an increasing function, so that means x is less than y if f of x is increasing. Okay, and if it's a decreasing function, we just reverse the inequality because it's decreasing. So increasing and decreasing behavior ultimately helps in solving the inequality, not the different function. That means if we know the characteristic, the increasing decreasing characteristic of log function, we don't need to know how do we solve log function. I mean, there's nothing different in that function in any other increasing or decreasing function as far as the inequality solution is concerned. Okay, so my point is, if we have to solve any such inequality, what ultimately helps us is the increasing decreasing behavior of that function. Okay, and of course it has to be a 1-1 function, then only we can remove function both the side and compare their input with the same sign. If fx is increasing, with the reversing the sign, with reversing the sign when fx is decreasing. Okay, now that's clear. Okay, now I think you all would have got the idea how to start with it or how to initiate. I will go for f dash x and check the increasing decreasing behavior of this function. So which type of function is it? So when you differentiate, you get minus 2 minus 3x square, which is of course always less than 0. So that means fx is a decreasing function. So that means f of minus x will be an increasing function. Okay, why? Because minus x is a decreasing function, so decreasing of decreasing is an increasing function. Okay, so now I will write f 2014 of x, which has to be less than, I suppose, f 2013 minus x. So I will see, as I said, the function on both the side has to be same. So do we have same function on both the side? Answer is no. This is composition for 2014 times, and here we have composition 2013 times. So I will write this one as f 2013 of f of x. Okay, I think none of you will mind when if I write that, isn't that, bachcho? Now this is same function both the side. Okay, now fx is a decreasing function, so f of fx will be an increasing function. f of fx will again be a decreasing function. So every odd subscript decreasing, every even subscript is increasing. So f of 2013 times composition will give us a decreasing function. So that means f 2013 t is a decreasing function. So as I said, if we know that a function is a decreasing function, we can compare their inputs but by reversing the sign. Okay, so now that gives us take x cube that side. Okay, so x cube plus x, and then we have minus 30, and then it is less than 0. Okay, so it's x minus 327, x minus 3 into x square minus 3x square plus 3x plus 3x square minus 9x. Yeah, 27 plus 3 is 90, no? So x is equal to 3, satisfying it. Okay, x minus 3 to x minus 3x square plus 3x square minus 9x. So we need, okay, right, we need plus x, so plus 10, less than 0. Now this is always positive. Why? It's a quadratic whose open upward quadratic whose discriminant is negative. So the only possibility is x is less than 3. Okay, so less than 3 means now the question is number of positive integral values of x. So there are just two positive integral values of x, that is x is equal to 1 and x is equal to 2. That's it. So the answer should be 2 here. I think you all would have got this question, its solution. And now moving to the next one. Y is equal to this contain 4 collinear points, then find the maximum value of greatest integer of a by 5. Okay, now see again, how did I look at this question? It's a 4-degree polynomial with positive leading coefficient. Again I'm repeating, it's a 4-degree polynomial with positive leading coefficient. So if I just try to draw the curve, okay, so see, either it will go something like this, I mean it will have 3 terms, okay, or the other possibility is can it have 2 terms? My point is it possible to have 2 terms? Let's try. So if I draw a curve, a 4-degree polynomial curve with 2 terms, what does that mean? That means after second term it has to go to minus infinity. It's not possible. Why? Because it's an even degree polynomial. Okay, so in case of infinity or minus infinity, it's going to the same, I mean it's approaching the same infinity. Okay, so leading coefficient, that's not possible here. So that means the only other possibility is that it takes only 1 turn. Okay, so these are the 2 possible curves for this any such 4-degree polynomial with positive leading coefficient. I think I'm clear to everyone. Okay, now see, first earlier when I was trying this question, again this question came in front of me as doubt. So when I tried this question, so I started with the roots, then all of a sudden I realized that there's no need of like going for a root. Why? Because see, can we have 4 collinear points? 4 collinear point, what does that mean? That means 4 points on the curve which lie on the same line. So if a line intersects the curve only at 2 points, you can't have 4 collinear points on the same curve. Okay, now that's the only case when you have the 4 collinear points. Now is this case dependent on the roots of the polynomial equation? Answer is no. Now see, I didn't draw the x-axis, the reference plane. If I draw this x-axis now like this and y-axis, it has no root. Or if I draw my x-axis now something like this and y-axis like this, it has 4 roots. So does this line, the white line, depend on my reference plane, I mean the x-axis? Answer is no. So point is, again, the only thing on which this statement depends is that this equation, this polynomial should have 3 turning points. So 3 turning points means f dash x equal to 0 must have 3 real roots, then only you have 3 turning points. So f dash x is 4x cube, then it's 27 x square plus 2ax, I believe, yeah, plus 9 equal to 0 should have 3 real roots. Now for this equation to have 3 real roots, its derivative, see, it can have 3 real roots only when its derivative, it has 2 turning points. Okay, so for 2 turning points, so its derivative 12x square plus 54x plus 2a equal to 0, again should have 2 real roots. Then only this curve will have 2 turning points. That's the bare minimum condition, not the sufficient, it's the necessary condition. Okay, so now for this to have 2 real roots, it's a quadratic D. So I can write it as 6x square plus 27x plus a equal to 0. So 729, okay, 27 whole square minus 24a should be greater than 0, not even equal to 0. Okay, so that means a should be less than 729 by 24, so less than 30 point something. Okay, so the maximum, so a by 5 is less than 30.1 something by 5, so the greatest integer. So the maximum value of greatest integer can be 6, nothing beyond it, the maximum possible value. See, they ask you the maximum possible value. Okay, so it may happen, I mean, if for this you may have 3 real roots, if not, I mean, but you can't have 3 real roots for this polynomial if a, greatest integer of a by 5 exceeds 6, that's it. Okay, so you can have it only when the greatest integer of a by 5, the maximum value possible is 6. So that's my explanation, that's my approach to solve that question. Moving to the third question, let f be a periodic function such that fx is equal to 1 minus cos pi x has a unique solution. Okay, so fx is not that, this is an equation. So this equation need to have a unique solution. So unique solution means, see, for that case, and this one is also a periodic function. Okay, then fx period can be. Okay, see, one thing is for sure, I mean, if the overall this function, say if I write g of x is fx minus 1 plus cos pi x, if overall this function gets periodic, then you can't have only one root. Then we can't have only one root, because the periodic function will have either 0 root or infinite roots. I think I'm clear. Okay, so that means this function should be non-periodic, and the fundamental period of this is 2, if I'm not wrong. Okay, the fundamental period of cos pi x is 2. Okay, so the fundamental period, fx is a periodic function, can't be a rational number, so it can be pi, it can be e is an irrational number, it can be root 3, it can't be 1. Okay, so I think the answer is A, B, C. So do we have answer here? I don't know. So you can check the answer. See, I am uploading these questions for you, the practice of for you people, bacho, as post on the channel. Okay, so go to the post section of the channel, there you will get its PDF, and here I believe because I always try to give the answer key with the question paper. Okay, so check it out there. According to me, the answer should be ABC. Chaliye, moving, and if anyone has any other thought process behind that question, so let me know. That's what I always say. So let fx be a function such that f dash x is, so we are given f dash x is 1 upon x square plus f of x whole square. X is greater than equal to 1, f of 1 is equal to 1. Okay, now among these two, one has to be correct. F of a is either less than equal to 1 plus pi by 4 for all a greater than equal to 1, or f of a is equal to 1 plus pi by 4 for all a greater than equal to 1. One of them has to be correct, and similarly one might be correct in C and D because they move to the same direction. The same curve here, the same curve, this one also. Okay, and the option is different, pi by 4. So yeah, so I believe again this must be a multiple correct question. Now see, can we solve this? I don't think. I mean, we don't have any tool. We don't have any tool means till this class, till 12th and the preparation for IIT. Of course, when you will go for higher mathematics, solving differential equations, so it's a separate topic in mathematics. Okay, so it's a separate topic, differential equation, solving differential equation, complete topic. Okay, so we have methods to solve equation, but that's not our concern, and that is a question in front of us. So we should know that if we can't solve it, you're given any method, so that means we don't need to solve it. Okay, so keeping that thing in mind, I started thinking. So now what I actually observed here, f dash x is always positive, fx is increasing, so f of 1 is equal to 1, so that means fx is greater than 1 for all x greater than 1. I think I'm clear, because x is equal to 1 is 1, fx is increasing, so for all x greater than 1, function fx is greater than 1, so that means the minimum value of the denominator is x square plus 1, hence the maximum value of f dash x is 1 plus x square, maximum value. Okay, now dy by dx, so 1 upon 1 plus x square dx, taking dx that side. Now dy and dx are finitesimal element, infinitesimal element. Okay, and we always consider them to be positive. Why? Because see, whenever we consider an interval, if you go to the basic calculus thing, so we consider the interval from x to x plus dx type of thing. Okay, so that's why I can take the liberty of taking to the right side. Now see, over an inequality we can apply the definite integration. See, can we differentiate an inequality without changing its solution or anything? Answer is no, we can't differentiate an inequality statement, but of course we can integrate. The definite integration as an operation we can use over the inequality. So I'm integrating it from 1 to y, because when x is 1, y is also 1, f of 1 is 1, and this also from 1 to x. So this is y minus 1, and this is nothing but tan inverse of x minus pi by 4. Okay, see, now let me be true to you all. The point, how did it strike my mind? First thing, the inequality. Second thing, presence of pi by 4. 1 okay, as one of the endpoint of the interval for all x greater than 1, for all a greater than 1, pi by 4. So to get pi by 4 from 1, the only function we have is tan inverse of x, and in the denominator here the form is clearly, I mean, it is hinting towards that thing. Okay, x square plus y square, tan inverse of x by y, tan inverse of y by x, that all started coming to my mind, and then all of a sudden I realized that this function is always an increasing function, and then it build up. Okay, that's how it started building up. So take one that side, so y is equal to 1 plus tan inverse of x minus pi by 4, so it's inequality not equal to, so less than equal to. Okay, now if it is less than equal to for all x greater than equal to 1, so as x goes, a tan inverse x is an increasing function. Okay, so if it's less than for this thing for all x, so it will be less than when x approaches infinity. So as x approaches infinity, this is less than 1 plus pi by 4, pi by 2 minus pi by 4, so it is y is less than equal to 1 plus pi by 4. That's a maximum possible value, and that too when x goes to infinity. So that means f of a is less than 1 plus pi by 4 as a is greater than equal to 1. So that's what I said. So this one is correct. Now moving to the next one. So y, I think there shouldn't be any fx. Okay, so maximum of f of a, greatest integer. So maximum value of f of a, so greatest integer of f of a, the maximum of. So of course maximum is 1 plus pi by 4, and pi by 4 is less than 1, so it is nothing but 1. That's it. So y is less than equal to x square. That's 1. And another one is x square plus y square is less than equal to 2. And area enclosed by this and y is greater than equal to 0. In both the case it's the same thing. So let's draw the curve. So how does the curve look like? One is a parabola another one is a circle, x square plus y square is equal to 2 with a radius root 2, center at origin, and this is the another curve, y is equal to x square. Okay, so can we have the point of intersection? So y square plus y minus 2 equal to 0. So y is equal to plus 2 minus 2, y is positive. So y is equal to, that's the, y is equal to 1. So when y is 1, x is also 1. And y greater than equal to 0. See, which region? So that's one region. Why? Because see, y is equal to, see, this is the curve for y is equal to x square. So of course when y is less than x square, it has to be below the curve, and for x square plus y square less than 2, it has to be inside the circle. So below the curve, inside the circle, above the x-axis, y is greater than equal to 0. So that should be the region, because using symmetry of the figure, it's symmetric about the y-axis. So I will like to integrate it from 0 to 1. So 0 to 1 x square dx, 1 to root 2 under root of 2 minus x square dx. Now just solve it. Okay, and twice of it, of course, twice of it. Solve this integral, whatever we get should be the answer. So whichever option is correct, we may then mark it. Now next question is, if a function satisfies this, then a period of f of x can be, see, again, this is again a very common type of question, but I took it as a practice here because of the presence of root 2. Okay, so how I started, see how I suggested my student to start here is, first of course I will replace x by x plus 1. Okay, because this is x plus 1, this is x minus 1. So at least this one will give us fx. So we get f of x plus 2 plus f of x is equal to root 2 times f of x plus 1. Fine. Now I have f of x plus 1 here. So I will suggest to replace f of x plus 1 from here. So we get f of x plus 2 plus f of x is equal to root 2 times f of x plus 1 is root 2 f of x minus f of x minus 1. Okay, so it's 2 times fx minus root 2 f of x minus 1. Bring it this side. So we have, rather I will take it that side, f of x plus 2 as fx minus root 2 f of x minus. So again replace x by wait. We have f of x plus 2 if I again try to replace it by root 2 times, okay, replace true, fine, wait, here now I will replace x by x plus 2. Why? So I will get f of x plus 4, bring it this side, minus f of x plus 2 is equal to minus root 2 times f of x plus 1. Okay, see, the target here was, that's what I suggested my student here, that try to get rid of root 2. So here I am seeing that I can get rid of root 2. How? This is one thing here. Okay, so just add this to this. So f of x plus 2 plus f of x is equal to root 2 times f of x plus 1. That's it. Gets cancelled, gets cancelled. So we have f of x plus 4 plus f of x is equal to 0. So f of x plus 4 is equal to minus f of x. Replace x by x plus 4, and then we have f of x plus 8 is equal to minus f of x plus 4. From here we know this is equal to f of x, hence f of x plus 8 is equal to fx. So 8 has to be a period. 8 has to be a period. So which can be a period? 8 can be a period. Whether 6 can be a period, 4 can be a period, we can't be sure. Okay, so 8 can be a period, rather 8 will be a period. Fx satisfy this, then f inverse etc. See, again see, that's what I said and keep telling you all in all these sessions, that I try to select even those questions which are seemingly difficult or complex, but when you approach it using the very basic approach, you find them to be a simple one. So this is one such question. So of course, mod of fx is equal to fx when fx is greater than equal to 0, and minus times f of x when fx is less than 0. Okay, so if I put this value here, so it's x plus fx 2 times f of x when fx is greater than equal to 0, and this is x minus f of x is equal to 2 times f of x when fx is less than 0. Okay, so this actually gives us fx is equal to x and fx is equal to x by 3. So actually see, fx is positive and fx is equal to x, so fx is equal to x when x is greater than equal to 0 and x by 3 when x is less than 0. Now you have to find the inverse. Okay, so the inverse in that case, in this case it has to be x, so f inverse x is equal to x when x is positive, okay, and this is 3x when x is negative. That's it. Now what you have to do, you have to just find out which one is satisfied. So of course the possibility is that either 3x this one or this one is going to satisfy. Now you have to check. Okay, so again, a mod of f inverse x is f inverse x when f inverse x is positive, and f inverse x is positive when x is positive. Okay, so when f inverse x is positive, it is 3f inverse x is equal to 3x, so it is x, so f inverse x is x when x is positive. Similarly, when it's negative, okay, so it will be f inverse x is 3x when x is negative. So that should be the answer. I think all of you would have got it. Otherwise, as I said, you just go on removing mod from there and substituting the value whichever satisfies the answer. Okay, so now quickly moving to the next one, question number 7. Let fx be this, where find the number of integral values satisfying the inequality 4 times f of x whole cube plus f of 1 minus 2x plus fx is less than 1. 0 to 4, f of 0, see, I just tried to solve this, is 1 and 1 minus 2x, since x is the input, okay, so it's 0 when x is equal to half. Okay, so for this, when we put x is equal to half, we get it 0. Okay, so again, I mean f of 1 minus 2x will be 1 when x is half. Fine. Okay, wait. And how much is the value of f of 1? F of 1 is 1 minus 1 is minus 4. Yeah. Number of integral values satisfying the inequality, this. Okay. F dash x. Okay, this is also always decreasing. It's a decreasing function. So this is a decreasing function, this is a decreasing function, this is an increasing function. But of course, this is fx whole cube, far stronger, far fast, it will decrease at a much faster rate in comparison. See, the rate of increase of this and this is comparable because both are having linear input. The only difference is when you differentiate it, its derivative will also get multiplied by 2. I mean minus 2, of course, that will only tell us that it's an increasing function. Okay, so it will just multiply by 2, but here you already have it's multiplied by 4. Okay. If you go for, chaliye, one more thing, f of 2, moreover f of half. Okay, f of half, because x is equal to half, we got there 1 minus half. Minus half, which is 0. Okay, wait. So if I say that g of x is 4 times f of x whole cube plus f of 1 minus 2x plus f of x, okay, then g of 0 is 4 plus f of 1 minus 4 plus 1, okay, which is less than 1. 5 is not equal to 1. I mean, this has to be equal to 1, so not less than 1. Okay, but g of half, g of half is 0, so this is 0, this is 1, and this is also 0, so this is again not less than 1. Okay, then comes to g of 1. G of 1 is 4, okay, minus 4, I'm sorry. So now that's done, that's over. G of 1 is minus 4, so minus 4 is power 4, which is very huge. I mean, in comparison to the value which you'll get from here, it's a huge negative value, so this is negative. So once this is negative, this is going to be, that's what I said. When you put x is equal to minus 2 and then minus 3 then minus 4, for all those things it is going to be far more negative, so it's always less than 1. So the point is, except for x is equal to 0, for all integral values of x in the interval, closed interval 0 to 4, that means at x is equal to 1, 2, 3, 4, this function is always negative and hence get less than 1. So the answer should be, to find the number of integral values, so answer should be, it has 4 values. Otherwise, see, we can try it the way we tried a function. I think we did it just now, no? Where we will differentiate it and then go for its, I think we did it in the last session, I just forgot. Okay, so we can assume it to be a function, I mean minus 1 is equal to g of x, and then check it whether it's an increasing or decreasing function, that's another way. But then when I realized that get this value and put this value here, we got 0, so I thought that we can get the values itself, so why to use any other method in that case. Okay, so that's the way we solved it. Now moving to this question, find all functions such that, see, since again I was solving this question for as a doubt, so we all know, but a student here has a doubt that whether we will get the solution or not. So I solved this question completely using the same classical standard method. What it says, replace x by 1 minus x. So replace x by 1 minus x. Okay, so I will be treating f of x as a variable a, f of 1 minus x as a variable b. So once we replace x by 1 minus x, we will have two equations in two unknown. Okay, now since we need f of x, all functions, so we need f of x, so actually we have to just cancel f of 1 minus x using elimination method. So I will multiply 1 minus x whole square here, both the side. Okay, and then subtract the second one from the first one. That's gone. So f of x, and this is, I mean, I'm not going to solve it, of course, but my point is I solved it for the student here and I got the answer. Answer is, I think, 1 minus x square. So just try to solve it. Okay, get f of x, we will get it here. See, I already wrote it in a way where we can simplify it. A square minus b square. Similarly, here you can have x common, here you will have 1 minus x common, then open and then take common and then do it, you will get the answer. Okay, so I have already solved it. I know we will get the answer, and I still remember the answer. Answer is 1 minus x square. If I'm not wrong, I mean, you can, again I will repeat, you can check it from in the post section of the channel. You will get the PDF and you will get the answers also. Okay, satisfy the equation. Okay, see, so it's a question based on functional relation. So since then the absolute value of the difference between the maximum minimum value of f of x is okay, so but I guess that I mean I almost guessed, I was able to guess the function here. Okay, how? Because I was saying that it's a polynomial of degree 4, I mean x and y. Okay, and in that case, if I'm taking it as in that term, so in that case this is a linear term. So fx or f of x plus y or f of x minus y has to be a polynomial of degree 3. That's how I started. Okay, so then in that case, see, If I write it as cube, so it will be x plus y whole cube, x minus y whole cube, and then you have x square minus y square common directly, and you have the answer. Okay. The only thing is, like, is it f of x as ax cube, f of x as whatever. I mean, what is a? Okay. So that was the only dilemma, but still I thought to solve it using method. So in that case, see, though it's not given, I mean, it's not given whether it's a differentiable function or not, I use differentiation, partial derivative here. And one more thing, I checked here to verify, I mean, x cube is an odd function, so to check it, I just try to get whether it's an odd function or not. We are given f of 1 as -2, and I try to get f of 0 also. Will we get it? If I put x is equal to 0, y is equal to 0, x is equal to y equal to 0 won't help. X is equal to y. If I put just a minute, so it will be 0, x is equal to y minus 2x, f of 0, x is equal to y is equal to 0. So of course f of 0 is 0, because x can't be 0 universally, not possible. So f of 0 is 0, we got it. Okay. And then see, I tried to check. So what I did actually, I replaced x by 0, keeping y as it is. So replace x by 0, so I have minus y, f of y, minus y, f of minus y equal to 0, because x is 0, so this entire thing is 0. Okay. So now minus y gone, so f of minus y is minus f of, it's an odd function. So that again verified that x cube is okay. I mean, fx is equal to cubic polynomial with single term x cube is fine. Now, but then again, see, though it's not given here, it's a differentiable function, but still, I thought to solve it using a method. So I just thought to see, that's again a method. The method says that differentiating the entire relation, keeping one variable as a, treating one variable as a constant. So if I treat y as a constant here and differentiate with respect to x, okay, so what do we get? So x minus y, so using product rule, f dash of x plus y plus f of x plus y. I think all of you agree, because y is a constant. Then minus x plus y as it is, f dash of x minus y, and then minus f of x minus y is equal to, so with respect to x, okay, so it's 4y x square minus y square plus 4xy into 2x. I think that's done, isn't that? Now I thought of substituting what? X as 0. Not y as 0, because when I tried substituting y as 0, everything got 0. 0 is equal to 0, that's what I got. I've already done this question. Okay, so put x as 0, so minus y f dash of y plus f of y minus y f dash of minus y minus f of minus y is equal to x is 0, this is gone, minus 4y cube. Okay. Now f of y, rather f of minus y is minus f of y, and one more thing, right? One more thing, and that is, if fx is an increasing, if fx is an odd function, okay, that's what we have already checked, its derivative will be an even function. Okay, so these two come together and we get minus 2y f dash of y. The derivative will be an even function, so I can replace f dash of minus y by f dash of y. Okay, now this and this, so that's 0, isn't that? Is that 0? I mean, I will replace f of minus y by minus f. It's not 0. That came out to be 0, I think. Check out once, bachcho. Is there any mistake anywhere? I differentiated with respect to x, okay. So can't find a mistake, but got it that day. Because now it will get, I mean, though we can try to solve it, but I don't think it will be that easy. So 2 2 2, okay. So chaliye, let's take it as x, I mean replacing y by x doesn't make any difference. So minus x dy by dx plus f of x is equal to minus 2x cube. I mean this is y. If I take it in down, so dy by dx minus 1 by x is equal to 2x square. So integrating factor, I think, I mean get it, but are we going to get a cubic form? I don't think. It will be e raised to integral of minus 1 by x, which is minus ln x 1 by x, okay. We get 1 by x, no? So integral of minus 1 by x dx, so it's e raised power minus ln x ln of 1 by x. So we get 1 by x. So we get here y by x is equal to integral of 2x dx, 2x square by 2 plus c. So y is equal to, okay, cx. But what about c? Okay, c is also 0. Okay, done. X is 0, y is x is 1, so putting x 1 by done. So y is equal to simply x cube, but that's not possible because the value at f of 1 is minus 2. Okay, f of 1 is not 1. Okay, wait. Let's try. C is not 0 in that case. Plus cx. Okay, so when I put, so it's minus 2 is equal to 1 plus c. So c is minus 3. So y is x cube minus 3x. So again it's an odd function. F of 0 is 0. It's an odd function. So that might be the answer. Okay, so that means that I committed mistake because here I remember I got it directly from here. There was no such term, and then I got it directly. So it's okay. It's fine. Okay, so I don't think there's any mistake in this case. Now this is the function. There's a mistake here. I mean this has to be n. This has to be n. Okay, and this also has to be n. See what happens is, so just observe it. I mean, though they have written it, they have written it as x. Okay, but I didn't get it in terms of x. Okay. And then also it's fine. Actually, okay. Because when I solved it, I wrote it as x square plus 1 upon x square plus 1 plus x upon x square plus 1 first. Now take 2 common from here. 2 times 2x square plus 1 over 2x square plus 1 plus x upon 2x square plus 1. 3 common. 3 times 3x square plus 1 over 3x square plus 1 plus x upon 3x square plus 1. See, the second term in all the terms within square bracket, that's going on continuously decreasing. Okay, now what? So this is 1. So this is 1 plus something, 2 plus something, 3 plus something, using n plus something. Okay. Now using the property of greatest integer, we can write it as 1 plus greatest integer of x upon 2x square plus 1, rather x square plus 1. Isn't that always less than 1? X square plus 1 in any case is going to be greater than x. Okay, so when this is less than, this is less than 1, this is 0. So this is nothing but 1 plus 2 plus 3 and so on n. So n into n plus 1 by 2. So there is no x. So f of x is this, so you have to just substitute it here. So it's a, it's a 4 degree polynomial here, it's a 4 degree polynomial here, it's a quadratic polynomial here. That means you will be able to simplify it, because infinity by infinity form can be solved to get a finite value, okay, non-zero finite value only when the degree of both numerator and denominator matches. By 4 minus n cube into n plus 1, I think by 4, that's what we have. By 4 is common, this is n plus 2. Now you solve it. I mean, you will get a quadratic in both numerator and denominator, because something will happen, I believe. This is a square. Okay, then only we will get the answer. I think this answer is 2. Now you can solve it, bachcho. Just simplify it and do it. Question number 11. If fx is a double differentiable function such that mod of f double dash x is less than or equal to 5. For each x in the interval 0 to 4. For an interior point in this, then the maximum possible value of mod of f dash 0. See, if I go for, if I consider f dash x is a function g of x, and largest possible value. We have to add, no? Let me try. Gx, then see, if I apply Lagrange's mean value theorem, because that relates f dash, a function to its derivative, okay, over the interval. So since I need f dash 0, f dash 4 separately added. So if I consider the interval 0 to c, okay, so I will write it as f dash c minus f dash 0. I am applying it at gx, which is f dash x, upon c is true for some f double dash x. X belongs to this. Now if I take mod, this is less than or equal to 5. C is positive, chalo, I can take it that side. The problem will be, again, how to separate it. Okay, now if I apply in the same alongwith in the interval c to 4, it will be f dash 4 minus f dash c upon 4 minus c is equal to, again, f double dash x. X belongs to this. Now if I again take mod, 4 minus c is again positive, so this is less than or equal to 5. So mod of f dash 4 minus f dash c is less than or equal to 5 times 4 minus c is positive. Okay, so 20 minus 5c, and one is f dash c minus f dash 0 less than 5c. Any other function. And f takes its largest value at an interior point. Okay, f takes its maximum value, okay, in the interior point. That means there will be a point C, any point, I'm not saying C, there will be a point where f dash c or d will be 0. Okay, let's put f dash c is 0. So that random point c is that point where the derivative is 0, where it is taking the maxima value. That's it. Okay, then we are done. Add them. So this is 0, this is 0, add them, we get 20. So f dash 4 mod plus mod of f dash 0 is less than or equal to 20. Largest value is 20. Done. See, we must read the question very carefully. Okay, now moving to the 12th question. Fx is a polynomial function and f alpha whole square plus f dash. Okay, that's simple. I mean that f of alpha has to be 0, f dash alpha has to be 0, and then it tells us one more thing, it's a polynomial function, so that means I can write fx as x minus alpha. It has to be a repeated root. Sorry, next thing is sorry. Okay, so it has to be a double root, x minus alpha whole square. Now see, okay, see, this is a box bracket, and whenever we have box bracket for limit, I will love to go for sandwich theorem. We know box of t is less than equal to t and greater than t minus 1. So box of f dash of x upon fx is less than equal to greater than minus 1. If I multiply both the sides by what we want within limit. Now you may say, I'm sorry, there's a problem. Once it will start, it will continue for some time. You have to be here. Sorry, really sorry, because I can't stop video here. Okay, so bear it for some time. I will try to finish it as quickly as I can. See, we don't know the sign of fx by f dash x, but the point is either positive or negative. In both the case, see, either we are going to have the same sign here, or they will reverse. Their position will get reversed. No other change. So this is less than equal to 1, and wait, x tends to alpha. Limit x tends to alpha. So it's a constant, doesn't make any difference. And this is 1 minus x tends to alpha. Now see, f dash alpha. F dash alpha will also have x minus alpha. Why? Because f dash alpha is also 0, and there will be some function h of x. So if you go for evaluation of this limit, this is 0 by 0 form. So you will get limit x approaches alpha 1 minus x minus alpha whole square h of x upon x minus alpha h of x. As x goes to alpha, this is 0. So this lie between 1 and 1. So the limit on both the sides is same. That's what I said. If they are going to be same, doesn't matter whether we have to reverse the sign here. I mean whether fx by f dash x is positive or it's negative. Okay, and hence we'll get the answer. So the answer should be 1. Sorry, Ocho. Okay. Monotonically increasing function for all x. F double dash x is positive. F double dash x positive means the curve has to be open up. So that's the curve of fx, open up, increasing. Okay, and the curve for f dash x, f inverse x will be something like this. Okay, open up. Now x1, x2, x3, since we need this, okay, so I will say consider 3 points, x1, x2 on the curve. They will form a triangle because any 3 points, either they are collinear or they form a triangle. Right at centroid, it's an open down curve. Okay, remember that. F inverse x1, F inverse x2. Okay. Now see, centroid, since it's an open down curve, centroid will always lie below the curve. If I draw a vertical line passing through it, the point where it meets the curve, its abscissa is going to be the same. But since it lies on the curve, the ordinate has to be this. Now tell me the relation. The point is below this, G is below G dash. So this has to be less than this. Okay. So F inverse x1 plus F inverse x2 plus Fn. So the first option is the correct, itself the correct option. I think all of you have understood. Okay, now moving to the, yeah, that's a very good question. I mean, why I'm saying, because for me it took time. So according to me it's a good question. Okay, just a minute. See, we have to write it as a function of x. As a function of x. Y is between 0 to 1. So to come out of any confusion, I replace y by t. Close 0 to 1. Okay. Now draw the curve of y is equal to t square minus xt mod, and taking x as positive. It has two roots, so that's 3. Why? This is x. Now, okay, we need mod, sorry. That's the curve. Okay. Now, see, maximum of this. If one, okay, what are the possibilities? 1 is greater, so x is less than 1. So either you have maximum here or you have maximum at 1. Only two possibilities. Now the vertex is at x by 2. X is less than 1, x by 2 has to be less than 1. Okay, so vertex is at x by 2. Now the value at the vertex x by 2 is x square by 4, bachcho, after putting mod. And value at 1 is x is less than 1, so it's 1 minus x. Okay, at t is equal to 1. Fine. Now which one of them is larger? Has to be the answer. Okay, so g of x is equal to x square by 4 when x square by 4 is greater than 1 minus x. 1 minus x, and both the cases when x is less than 1 and greater than 0. I think I'm clear, because we started with x greater than 0. Solve this inequality. So x square, I mean greater than 0, open upward quadratic positive is beyond the roots. So the roots are 32. Minus 2, 2 root 2. Plus minus. So minus is out of consideration because x has to be positive. And between 1. So this is when x lie between and this will be when x lie between 0. Okay, because less than 0 between the roots. I think you all be able to do it. So that's one. Now what if x is greater than 1? So if we have 1 here, in that case what? Now again there are two possibilities. X is greater than 1 but less than 1 is less than x by 2. Okay. X is greater than 1 and 1 is greater than x by 2. Okay. So that means x belongs to 1 to 2. So g of x is when x belongs to 1 to 2. So again, When that happens, again the maximum value is x by 2 for sure. Okay, so x square by 4 when x belongs to 1 to 2. What if 1 lie before this? T can't go beyond 1, so that means the maximum value at 1. So x is greater than 2. So this is nothing but 1 minus x. So that's the function on the right side of 0. 0 to this point, this, from this to 1, this, 1 to 2, x square by 4. So that means from this point till 2 is x square by 4, and from 2 to infinity is 1 minus x. Now the last thing, what if x is negative? Okay, see, if x is negative, in that case the curve will be something like this. And since t lie between 0 to 1, the maximum is at 1, that's it. So when x is negative, g of x is 1 minus x mod. Okay, and since x is negative, so mod, wait, for x greater than, okay, right, here it's mod, I forgot that. So x greater than 2, so it will be actually x minus 1. X less than 1, it will be actually 1 minus x. So now you draw the curve. Y is equal to g of x. Negative side, it's 1 minus x. So from 0 to minus 2 plus 2 root 2, then from 1, then from 2, and so on. So from this to this, it's again okay, 1 minus x continued, something like this. From this to this, it's x squared by 4 wait, okay, minus 2 plus root 2 to 1 is x squared by 4, and 1 to 2 is x squared by 4. So till 2, 1 has no problem, till 2 it's like this, and then again it's a line. So the maximum value is here for sure. So put x is equal, and we got the answer. I mean, when we were solving it, so that was an interesting question for me. Okay, so either you put it here or you put it here, we get the answer, and the answer, if I'm not wrong, is 3 minus root 8. Okay, so that's it. I think that was the last question, I believe. Yeah, that's the last question, bachcho. Okay, so that's it for today. We'll be continuing with another maybe integral calculus or miscellaneous question in our next session, bachcho.